Again, welcome back for Math 307. Now we are talking about the Lie equation. And the Lie equation, we shall calculate the transformation 1.1 of one parameter group by using Lie equations. This is why we introduced the Lie equation. Let's define the Lie equation. Of course, you have in my notes there some definition of the Lie equation. I gave it by 3.1 and 3.2. I will write 3.2, the Lie equation, okay, to find this transformation. 1.1, the one parameter group G are defined by solving the Lie equation. The Lie equations. What's the Lie equations? In fact, the Lie equation is given by 3.1 in our notes and 3.2. I will use the notation for 3.2. I will write it here. dx bar by dA. You can calculate this by solving this equations zeta of x bar, y bar, and x bar at a equal to 0 equal to x, and the second equation, Lie equation, dy bar by dA equal eta of x bar, y bar, evaluated at y bar equal to a equal to 0 equal to y. This is, I called it 3.2 there. So this is two differential equation. The dependent variable is x bar and y bar, and the independent variable is a. So you need to solve this equation to find the zeta and eta, to find x bar and y bar. Let's give an example, and it's example number 1. It's there. So if you go to the notes, you will see it. I will explain it here. So examples. 1. X bar equal, I will formulate the Lie equation now. X plus ya, y bar summed to y minus xa. Now we want to calculate the x bar and y bar from the Lie equation. The generator is defined for the group. So let's find the generator. It's capital X zeta d by dx plus eta d by dy. And we can write it here. X bar, X capital, the generator. And we can see from the definition of the, here, this is the, you can see we can write it here exactly y d by dx plus minus x d by dy. Here zeta equal to y, the coefficient of this x bar here, and eta equal minus x bar, you can see it here, this one. So sorry, it's let's clean this here. Now turn back, so it will be just x minus x. Okay, so zeta equal to y and eta equal minus x. We find it from the x bar and the y bar. Let's solve now the Lie equation. The Lie equations. I will write it here, dx bar over dA equal to zeta, which is equal y here. Okay, evaluate zeta and eta at, let's evaluate this before that, before I write the Lie equation. Okay, if you see zeta of x bar, y bar, you need already, you have zeta, so it will be just y bar. You substitute here, and eta of x bar, y bar is just minus x bar. Okay, so we have the equation. So the Lie equation, we can write them here. Okay, dx bar over dA equal to y bar evaluated at x bar with a 0 equal to x, and the second equation dy bar by dA equal minus x bar. Okay, evaluated at y bar a equal to 0 equal to y. This is the Lie equations now, what we have. After solving this Lie equation, from the first equation, if you differentiate with respect to a, so you get here, from the first equation, this one, you get d square, differentiate again, of x bar with respect to a, dA square equal to dy bar divided by dA. And you will replace this from here, equal minus x bar. This is very easy equation, second order differential equation. Okay, plus x bar equal to 0. Let's solve it now again. And this equation, d square x bar over dA square plus x bar equal to 0, we know from 205 course in the first beginning differential equation, this general solution will be x bar cosine and sine. This is the solution. C1 cosine A plus C2 sine A. This is for x bar, and as we see that dy bar, okay, so this is dx bar, and y bar of A is just the derivative of this from the first equation. So derivative dy bar will be the derivative, so it will be y bar of A. Just you take the derivative of this one, it will be minus C1 sine A plus C2 cosine A. So we find x bar, so we solve the system and we find it, and we need now to evaluate at the initial, so x bar at A equal to 0 equal, put A equal to 0 here, which is equal x bar of 0, and x bar of 0 will give you cosine 0, so it will give you only C1, and this C1 equal to x from the initial condition. The same y bar at A equal to 0 means that y bar of 0, so it will be sine A 0 and cosine, so it will give you only C2, and this is equal, C2 will be equal to y. So we find now, if we retain and we substitute, as we see the x bar, then x bar of A equal x cosine A, this is the one parameter group, plus y sine A, and the y bar of A equal y cosine A minus x sine A. If you see here, when we define, we go to the x and y and see it. So this is the x bar and y bar. So this will finish the example for finding that. I gave another example in the notes. You can do the same. It's just, I just want to start a little bit of it. In the example of the note, if you see example 2, we take infinitesimal transform x bar. Let's example 2 I will write and just give you a hint of it. X bar, the same you do for the, it will be x plus ax square, and the y bar transformation, this is the transformation y plus ax y. Here zeta is just x square, this one zeta, and eta is this one, which is xy. So your transformation usually, which is given zeta d by dx plus eta d by dy is given by x square d by dx plus xy d by dy. This is the generator, the symmetry of your group generator or symmetry. Okay, symmetry of the group itself, which is very important. So in example 2, we show you how you calculate. You need to calculate again the same what we did, x bar and y bar. And if we complete, what you will see there, I already do it in the notes, x bar equal to x, as we did in example 1, minus 1 ax, and y bar equal to y over 1 minus ax. Is the one parameter group. And you can read this example in details in my notes, and if you have any question about it, you can ask me through the chat. Thank you very much for this lecture, and